Hello my dear students, I hope everyone is in good health. So today I will continue with the same lesson, physical and chemical changes, the topic characteristics of physical change. Characteristics. We have already discussed the definition of the physical change. At that time I have explained you that no new substance will be formed, there will be no change in the chemical composition, the change is reversible and temporary in nature. And what is the change will be there? There will be only a slight change in the physical properties. That means either there will be change in the state, in the size, in the shape, in the color. Those are the changes we often see in the physical change. Now let us explain one by one the characteristics of the physical change. First point, no new substance is formed. Let us take one example to explain it clearly. Water to ice. We often see that the water at room temperature remains in liquid state. Now when we put it in the diffuser of the refrigerator below 0 degree or at 0 degree, it changes to solid state, that is known as ice. So change of state is occurring. But the chemical composition, that is the hydrogen and oxygen combination of the water, remains the same. That means properties of water, whether it is chemical properties of the water, remains the same. And what about the composition? Composition also remains the same. It remains the 2:1, the composition ratio, everything, and it is the combination of hydrogen and oxygen. It remains the same. There is no change in them. So as a result, what happened? No new substances formed. Then what is the slight change we find in the characteristics of the physical change? Only a change in the physical state we find in this process. That means it changes from solid to liquid. When we get this change? When we slightly change the condition of the by which it requires to be changed. That means condition. What is the condition we put here? We put the condition, that is the temperature. When we increase the temperature, it comes back to liquid state. When we decrease the temperature, that is 0 degree or below 0 degree, it comes back to solid state, that is ice. Now let us go to the second point. The second point says that the change is temporary and reversible in nature. That means they are temporary. Anything temporary means they are reversible. They can come back to its original state. But how it will come back? If you change the conditions. Again we are talking the same example with that. That means when ice kept at the, what condition we have taken here? We have taken the condition, the temperature. Now what happened? By changing the temperature, we find that the ice at water at 0 degree, it changed to solid state. That is, which is known as ice. And when it is converted to room temperature, it comes back to liquid state, known as water. But there is no chemical composition change. That means it remains as water as a H2O. In the formula there is no change, and that's why in the chemical composition we find no change in the water. Only the state is changing from solid to liquid. When we decrease the temperature from room temperature to 0 degree, when we change the room temperature to 0 degree, it changes from water to ice, and reverse takes place when we change from 0 degree to room temperature. It again comes back to its original state, that is water. So we can easily say that the change is temporary and reversible in nature. Similarly, we can take another example also, like powder sulfur. Powder sulfur, you know sulfur is, this is the first example if I took, this is the second example. Sulfur is yellow color powder. It is a yellow. Now when we heat this powder, what happened? It changes to yellow liquid. Again we find that the powder, that is solid, changes to liquid when we increase the temperature. Similarly, when we cool it, when it is cooled, it comes back to again yellow solid sulfur. That means change of temperature. What is the change of temperature condition we put? The slight change of temperature makes the solid state changes to liquid, liquid state changes back to solid when it is. Let us come to the next point. The third characteristic says us that there is no change in mass during the physical change. Let us explain this with the help of an example. I took a empty beaker. After that I put some solid wax in it. After that, first of all I weigh the empty beaker. After that, with the solid wax, I weigh it. Let it be 5 gram. Okay. After that, I start heating it, this beaker. When beaker is being heated, this is the symbol of heat. The solid wax melted down and it is in now molten wax. Then again with this molten wax along with the beaker, we again weigh this. We find that the weight of B and weight of C are same. There is no change in the weight. That means it proves that there is no change in mass when the physical change is going on. That means what is the physical change is going on? Solid is changing to liquid. So when the solid changes to liquid state in the physical change, there is no change in mass. So let us come to the next and the last point is there is no gain or loss of energy. Now we will see the example of the energy, that is the heat energy over here. Now when we heat water, we find that the heat energy is getting absorbed. That's why the water becomes hot. Then what happened? The heat energy is getting absorbed when we heat water. Now coming to when the hot water, when we start cooling it, what happened? After some time we find that the water becomes cool. Then why it happens? Because the heat energy get released. Now when we calculate this heat energy absorbed and the heat energy released, we find that they are same. Whatever the amount of energy has been absorbed by the water, and the same water when it is being cooled, the same amount of heat is being released. So net there is no loss or gain of energy takes place. So these are the basic characteristics of the physical state, physical change you can say. And since you all are having the books with you, you go through the examples which have been given in your book. In continuation of the physical changes, we will now discuss about the interconversion of states of matter. Let us see what is interconversion of states of matter. That means there will be no change in the physical change will be changing from its states, and there will be no change in the chemical composition, and the total mass remains the same. Let us prove with the example. We are taking the example of ice. So first we will convert from one state to another state. So by heating we are doing the conversion. We took solid ice cubes in a first vessel or first beaker. Now we start heating them. It converts into liquid form, that is the water. Okay, and we continue our heating. When it goes above 100 degree, then what happens? It changes to water vapor, or we can also name it as a steam. It is the gaseous form. We find that how the change of state takes place from solid to liquid, liquid to gas by changing the temperature. What is the condition we are doing here? By changing the temperature. Now, as soon as we remove the heat, it starts cooling. When it starts cooling, the water vapor condenses to liquid. Then it gets condensed to liquid. Then after cooling, then the second step takes place, that is the cooling process. Further cooling to below 0 degree or 0 degree centigrade, we find that it changes back to solid state, that is ice form. That means we start from where we come back to there. This is known as the first stage is the conversion, and again we come back to the original product, that is the original substance, that is the ice. Total system is known as what? Interconversion of states of matter. You can name it as an interconversion of states of matter because we know that solid, liquid and gas are all different forms of matter only. Or you can take the example of ice, you can say interconversion of states of ice. It remains the same. Now students, we will talk about the characteristics of chemical change. Let us see what are the characteristics you have learned in the physical change. The opposite will be there in the characteristics of chemical change. In the physical change we have learned no new substances form. Here what will be there? New substances form. Let us take an example. Iron. Iron is a grey color metal. It is a solid plus sulfur. It is a yellow powder, okay, and iron is a grey solid shining metal. Now you will see here that iron has a characteristics. It is a magnetic substance. It gets attracted by magnet. And what about the sulfur? Sulfur is a yellow powder and it highly soluble in a organic solvent named as carbon disulfide solution. Okay. These are the characteristics of the two elements I am telling you separately. Now it is a yellow powder, it is a grey solid, and it is magnetic in nature, and it is highly soluble in carbon disulfide solution. Now when we react them, this iron and sulfur, when chemically react, that means when heated chemically, what they will give? They will give iron sulfide or ferrous sulfide. It is a greyish black solid. Now the characters which I have told you about the iron and sulfur separately, you should get here also. But should we get this? No. When we will test this with the magnet, we will find that it is non-magnetic in nature. And when we dissolve this in a carbon disulfide solution, we find it is insoluble in carbon disulfide solution. It is the formula of carbon disulfide. So it is insoluble. So what are the main criteria you got from here? A total new substance is formed when these two elements react chemically and formed a new substance whose characteristics, properties are totally different from the elements from where it is made up. Okay, the first point is clear. Now coming to the second point, change is permanent or irreversible in nature. If it is permanent, that means it is irreversible, cannot be come back to the original substance. Let us take an example. You know very well, paper or wood, when heated or burned, what happened? They change into ash. Now whatever the quality and whatever the work you can do with the wood and paper, can you do with the ash? The total property, characteristics, physical, chemical nature of the ash is totally different from that of paper or wood. And once it will be prepared, it cannot be returned back to this paper or wood again. That means the change is totally permanent and cannot be come back, means it is irreversible in nature. Now the third point we will discuss now. The third characteristics we will see in a chemical change, that there is a change in mass. How we will see that there is a change in mass? That means there should be a loss or gain of in mass when the chemical reaction will take place. Let us take an example of this. When magnesium burns in open air, that means oxygen, where you know it needs oxygen for any burning. So when magnesium burns in air, by taking the help of oxygen, it changes to magnesium oxide. When it changes to magnesium oxide, there is a slight increase in weight. And that's why when slight increase in weight means what? There is a gain in mass. And how will you prove this experiment? With a slight activity you can do, that way you have to take one small beaker, empty beaker, you first weigh it. Then after that you weigh along with the magnesium, you weigh this. Then automatically you get the weight of the magnesium. After heating, then when it converts to magnesium oxide, again you weigh it. Then you will find that there is a slight increase in the weight of the magnesium oxide, which proves that there is a slight change in the mass in the chemical reaction. Now coming to the last point of this, that is the exchange of energy takes place. You know that any burning of fuels, the two common byproducts always comes out, that is carbon dioxide and water vapor, and lot of energy. Lot of energy can be in the form of heat and light, sometimes in the form of heat also. So let us see an example. When paper burns in open air, that means it is taking the oxygen. Then when any paper burns in open air, that means in presence of oxygen, it changes to two byproducts, that is carbon dioxide and water vapor, and lot of energy in the form of heat and light is produced. That means energy is, either energy will be given out or energy will be taken in. So many of the cases you will find that energy is being absorbed, and in many of the cases here we find that the energy is being released. So in this way we find that the energy exchange of energy takes place in chemical changes. So these are the common characteristics we discussed today about the chemical changes. You will find some of the examples given in the book of the chemical changes also, physical changes also. So please learn them and practice them nicely. Now last part of this lesson is the burning of candle. Now burning of candle is a very good example where physical and chemical changes takes place simultaneously. What is the meaning of simultaneously? To take place together. Now let us take an example with the help of the burning of the candle. I have shown you a little bit the diagrams of this, that when the candle is being burned, you will see that the flame is burning at a high flame. Then what happened? Side by side you find that the wax is also getting molten. Then when the molten wax, that means it is in the molten means liquid form. When it is getting changed into liquid form, it comes down on the floor and gets solidified. That means changing into liquid form and again coming back. That means it is fine. First is the solid form, solid wax was there. After burning, what happened? It changes into molten, again coming down to the, and when it cools down on the floor, it gets back to solid wax. That means melting of the wax and getting solidified is the example. It is the example of physical change. That means physical change is the there is no loss of wax or anything, only the physical change of state from solid to liquid and liquid to, again on cooling, liquid to solid. Then coming to the chemical part. Then what is the chemical change going on? It burns with a high flame. At that time we know that any burning of a fuel, it gives two byproducts. Two common byproducts are always given to the, when it burns in open oxygen, when in fuel, it gives two byproducts, that is carbon dioxide and water vapor. These are the new two products which comes out after the burning of the flame, and we know that the two new byproducts which come out, and it always it goes and mixes into air, and lot of energy also comes out with that. And this is an example of what? Chemical change. So we find that burning of candle is a very good example of physical and chemical change taking place together. So students, I hope you have understood the chapter. So study nicely at home since you have got the books with you. So prepare yourself, and in the next PDF I will give all the exercise question to you which will help you out. So keep learning, be in good health. Have a good day. Thank you.